Section 8.5, modeling data with sinusoidal functions. So this is going to look similar to the last two chapters. We're going to have data and we're going to enter it in. Now, normally we've been using Excel and creating graphs, and this is different data than what I'm going to do. But the problem is when we make our scatter plot, there isn't a spot when we go to trend line. When we go to more options, there is no sinusoidal way to make to put the equation. And so I just made a line there actually. So there isn't really an easy way. So what we're going to have to do is interpolate and extrapolate. Now, I don't prefer Excel. I prefer to use Desmos graphing calculator because then once I've entered the data, I can zoom and I can trace a lot easier. So we're going to use Excel, or sorry, not Excel, we're going to use Desmos. So we go to Desmos, and to enter data, I've already entered some data. What we're going to do is you're going to go to the plus sign on the next equation and go to table, and that's going to allow you to enter. So I've already gone ahead and entered a whole bunch of data, and I've gotten a graph. Once you enter the data, it's really important that you go here. You're either radian in degrees, usually in degrees, and then you look at your actual data. You see my x values looks like it goes from 0 to about 730. So maybe I want to go from like negative, oops, negative 100. I don't know why this keeps negative 100 keeps putting me out, and I only go up to 730, I think it was, so maybe I'll go to 800. So my x values are there. My y values, you'll see, go from, there's a maximum of only a little over 16, and it never goes quite below like 7. So, I mean, negative 2 to 24 is a little bigger than it needs to be. I could have 0 to 18 probably. So it just, sometimes you'll put all your data and you won't see anything until you've changed those menus, those windows. So this is what my graph looks like. Beautiful graph. I can tell that this is sinusoidal. I can tell that this is a sine graph. Look, it's repeating. It seems to be following a pattern. So we're going to use some of the principles we used in 8.4 to try and come up with equation and solve this problem. So let's read the problem that this data is from. Celeste lives in Red Deer. The predicted hours of daylight for 2 consecutive years are shown. In the second year, the spring equinox will occur on May 20th and the fall equinox will occur on September 23rd. Compare the hours of daylights on these 2 days. So notice first of all that I entered in the day number, and instead of entering the date, because this is data that makes a little more sense. So my x values are the days, and then my y value is the length of day. And that makes sense. It's that cyclical or periodic, right? It isn't constantly increasing or decreasing the hours of daylight. Every year it kind of repeats a cycle. So let's look at my graph. Oh, what we're going to try and find out is March 20th in the second year. So how many days from January 1st is March 20th? Okay, well, March 1st is 425, so then to get to the 20th would be 19 days later. So we're looking at day 444. So on my graph, I really want to know what happens on day 444. So there's 450, oops, there's 450, so 444 is somewhere around here. So I'm guessing there's over 12 hours of daylight. So that's called interpolating. The other thing I could do is I could actually make up a function, a sine function that models this data. And I think that's what I'm going to try and do. So when I look here, my amplitude, it looks like it goes from about 5, 6, 7. So let's say that's about 8 to 16. So my amplitude is going to be 4. So halfway between 8 and 16, if I go 16 minus 8 divided by 2 is 12, it looks like my midline is going to be 12. So if I wanted to make a graph, I would say my midline is about 12. My amplitude is about 4. And what I did it was just trial and error. So I actually made this graph and I said, oh look, that's a graph. Now I need a shift. and I need a horizontal shift. So what I'm going to do is I'm going to subtract some value. And all I did was I did trial and error. I can kind of see that I want this point to move over that much. So that's about 75 degrees. So I tried 75 degrees. That was close, but it looks like if I jutted over just a little bit more, I'd be a little more successful, 80. And then I also saw, you know what, there's something not quite right about my amplitude and my midpoint. So I just moved my midpoint a little bit and I increased my amplitude. Because remember, those are very rough guesses, and I got a pretty good approximation. Maybe I could shift over just a little bit more. Let's try 82. Now that's a pretty fabulous graph that models that. It's not exact. So anytime we do answers, we're not going to get exact values. So now what I was asking is I was asking when X was, when the date was 400 and I said, okay, what was I doing again? I'm confused. I said I wanted it on May, right, the 444th day. So I could actually do the math and sub in 4.5 sine 444 minus 82 plus 12.3. I want to have the right brackets. Plus 12.3. So I could actually sub in that value, and I would see that that value was 12.4, or about 12.4 hours of daylight. Okay. The next question it asked me was, well, what about fall equinox on September 23rd? Well, September 1st is day 609. September 23rd is another 22 days later, so day 631 is what I'm looking for. So again, a couple ways I can actually look at, okay, well, there's 650, 639. That would be 625. We're looking somewhere around there as well. So I could actually put in the value of 639. Wait a second. I think it's 631. I think I did that wrong. Okay. September 21st is 609. 22 days later to get to the 23rd. Yeah, 631. Sorry. 631. I could actually put it in as 631. Okay, and I can see that that value at 631 is right here. It looks like I'm looking at about 11.5, or again, close to 12 hours of daylight. And that makes sense, doesn't it? That on the summer and fall equinox, when there's the most sunlight, that there's 12 hours of sunlight. That makes sense. Okay, so I think I'm going to get you guys to do most of your questions by entering your data into Desmos, trying to come up with an equation using A, B, C, and D values that we learned in 8.4 to try and come up with an equation that best fits. Another option that you can do, this is kind of cheating, is we can put a slider for A, a slider for B, and I can't remember how to do this. B, yeah, add a slider for B, add a slider for C, and add a slider for D. So you can actually, I'm adding a slider, oops. Okay, and then you can actually play around with the values of A, B, and C and see how that affects the graph. So right now my graph is not working for some reason. Why is it not working? I think I have a space somewhere. I shouldn't have space. For some reason it's not working, but let's anyways, I don't know why it's not working, but you can actually do graphs why don't you like me today? And actually play with the slider to find out the values of A and how that affects the graph. I'm just going to pause and see if I can get it to work here. Okay, I needed one extra set of brackets. So this is the general form of the sine graph, and this is what the graph looks like with the values that are given. But you can see when I change A, what happens, and then I can change the rate, the interval, and I can actually play around with, okay, well, what happens when I go, oh, look, the more I move up, the closer I get to that graph. Looks like I might also need to change my C to shift it over. I definitely need to change my B to stretch it out, right? I do need to stretch this graph out a little bit. Oh, oops, that looks closer to what we want. And then we can just play with trying to actually fit this graph. Looks like I need some more stretching that way. I need to move up my midline for sure. So I need to move it up. Okay, I need to move over some more. It looks like I need even more than 10. I'm going to go up to 20. So we can also do, if you're not even sure where to start, you can do some playing around in this way to try and get it to fit. Try and shift things around. Probably easier to actually do the math, but sometimes putting a slider is a little helpful too. And so when you go to actually write an equation, if you just go y equals a, y equals x, and then let's say I add an a, sometimes they'll just let you add a slider. It's not letting me do that now, of course. X plus a. Anyways, sometimes they let you do sliders, but it's not, of course, when I'm making a video, let me do it. Okay, so Desmos, enter in your data, try and make the graph to fit. You can either interpolate or extrapolate by zooming, or you can actually get the equation of the graph to try and help you actually find the exact value.